Good afternoon. This is Kyle Welch with RCR Wireless News. Thank you for attending VoLTE Up Close, 5 Essential Steps for Successful Deployments, presented by Ixia and Informa. Our presenters today are Pierre Lynch, Senior Technical Product Manager at Ixia, and Mike Roberts, Principal Analyst at Informa, Telecoms and Media. Just a reminder to everyone that within 24 hours of this webinar, we will provide you with a link to the on-demand version of today's webinar. During the webinar, we encourage everyone to submit any questions you may have via the control panel, which will be answered at the end of the presentation. With that being said, I'd like to turn the presentation over to Mike.
Thank you, Kyle. Thank you all for coming. I'm going to be talking about voice, LTE, and VoLTE. A little bit on the broader mobile voice and LTE markets, and then zeroing in on the VoLTE market. On to the next slide. Sorry, just making sure we're advancing. There we go. These are the contents of my presentation. Quick introduction, mobile voice, LTE, a little bit on the OTT threat to the mobile operator community, and one of the answers to that, LTE voice, and as part of that, voice over LTE. And then I'll do a quick summary before handing over to Pierre at Ixia. Mobile voice trends. So as many of you will know, voice really is still the vast majority of mobile revenues globally. We do a lot of data gathering and number crunching at Informa, and our numbers for this year for the global mobile industry, the voice market, $634 billion, 62% of total mobile revenues, and you see that data revenues obviously account for the rest of that, a not insubstantial $385 billion. The only problem with that voice revenues is, as you may know, is that it's shrinking. We see that $634 billion this year shrinking to $579 billion by 2018. Of course, the other side of that story, as you see in this slide, and I detail a bit more here, is the data revenues are very much offsetting that decline in mobile voice revenues. With the data revenues we project going up $290 billion from 2013 to 18, and that will lead total mobile revenues globally to go up by $235 billion. So that's quite a positive story. But when you zero in, obviously the world is a big place. When you zero in on individual markets, which I've done here, I just took the UK as an example. There's actually some other markets where voice revenues are in more decline. But here in the UK, you can see the voice revenues dropping off, from 12 to 9 billion we project over the next 5 years, and the data revenues, just compensate for that decline, and overall revenues go up. But I could pick a number of markets, country markets, in addition to individual carriers, where those overall revenues are not going up, where the decline in voice revenues is greater than the increase in data revenues, and carriers know they have a problem and know they have to do something about it. So on to the LTE market. I think many of you will know that it really has been an amazingly successful technology in the mobile industry. We're now at near 200 live LTE networks globally as of September. In fact, as of now, we're over the 200 mark, and these, the areas you see in blue are the areas with live LTE networks, and it's a challenge to track because the launches come so thick and fast these days. Of course, along with that, you have subscriptions, really ramping from the beginning of the LTE market in late 2010, a little bit before that, to now we've seen, growth in global LTE subscriptions north of 160 million. And you can see the regional split. It's still the real bleeding edge markets of the US, Korea, Japan, still accounting for the bulk of subscriptions, but going forward, that is going to be balancing out because of the deployments I mentioned, and as other regions scale and operators scale, of course, you'll have subscriptions in those regions picking up. And this is something that's quite relevant, as the other slides have been, hopefully, to VoLTE, is the LTE penetration, subscriber penetration in particular markets. And this chart is showing LTE subscriptions relative to total mobile subscriptions in these markets in June of this year. And you'll see Korea, which has north of 40% LTE subscription penetration at that time, and this is directly related to the fact that Korea was the first market to launch voice over LTE. And similarly, you'll see some of the countries that will be leading the way in VoLTE having the high LTE to mobile subscriber penetration for reasons I'll go into a bit more later. So the over-the-top threat, I think it's something we're all aware of in the industry. I think we're all aware as end users. There's a lot of great applications out there that we use both as consumers and as business people. I won't go into great detail on these because I know that many in the audience will be aware of them, but you have VoIP, over-the-top VoIP providers, and you can see the list there from Skype and Facebook, BlackBerry's BBM, and on down the list to Fring, Tango, Reptel, and others. Of course, some of those also provide messaging, some more focused on messaging. I guess WhatsApp would be a classic example of a more messaging-centric over-the-top provider. Skype, Facebook, and others also doing that. KakaoTalk, which is very relevant in the Korean scenario and elsewhere. And then also providing video and video chat. And again, a number of the sort of full-service OTTs, if we can describe them that way, such as Skype, provide that along with Apple, Line, Fring, and others. So, and I think it almost goes without saying that we've seen these services really impact carrier services and revenues, particularly in certain markets where the penetration of some of these OTT applications are quite high. There's actually quite a lot of geographic variation in this, but in certain markets we've seen a direct impact on service provider revenues and a pretty substantial impact in a number of markets in Europe, also Korea and elsewhere. So clearly something the carriers are addressing and need to continue to address to carry on with the voice revenues and data revenues I spoke about earlier. So I think we'll know as consumers that we're all using these services. You could certainly argue in some cases that these services have improved on traditional communication services, and that's why they're so compelling. Of course, the price is obviously compelling in a lot of cases, being free, but this table is just something that we've done on the carrier response, particularly the mobile operator response to the OTT threat. And I guess on the, going down the first column, we have do nothing as a strategy, which was fairly prevalent early on. Thankfully, is less so. And we just have the simple green, yellow, or red for green, whether it works, yellow sort of, and red, it really doesn't work particularly well, sort of low effectiveness. And you'll see do nothing, has a lot of red there. Clearly, I think we're sort of moved past that. Fighting the OTTs, which again was a fairly common strategy, was not a very future-proof strategy. I think many, but not all carriers have realized. Neutralize can be a little more effective. It's not going to last particularly long. and it's it can be quite a safe option, but it's still probably not the best option in our view. And we get to the last two. That's really where we see the most mileage for carriers in responding to the OTT threat. They can partner with OTT providers. We've seen many examples of that. I won't really go into, but some of the leading OTT providers have quite prominent partnerships with carriers where they're trying to bring the best of both worlds to subscribers. Carriers can also, and again we've seen many examples of this, rather than partnering, effectively copy what the OTT players are doing. We've seen a lot of that. Telefonica, more carriers than we can name in the time allowed have launched, sometimes acquired, sometimes developed in-house OTT services that they have launched in competition with existing OTT services, and that's really where we see the strategic mileage for carriers, and that's also where new platforms and services such as VoLTE fit well, and can even extend this strategy, these strategies of emulating and even taking the sort of OTT concept further than the OTTs have been able to do themselves. I probably won't go into all the details on this slide, but one of the responses of carriers, I guess, really in the emulation or copying and extending to a degree has been the launch of RCS, Rich Communications Services, and Join. And I've just listed some of the commercial launches there. We've seen it in Europe, in particular, led the way, and then more recently we've seen launches in South Korea and the U.S. And those launches by the South Korean operators you see there and Metro PCS in the U.S. were actually on top of RCS, on top of VoLTE, and so are probably most relevant to our discussion today. Of course, you can also deploy RCS without VoLTE or even LTE for that matter, but we'll focus more on the LTE and VoLTE side, of course, here. So moving on to the LTE voice segment, and I'll just say briefly that I use this term sort of purposefully, that I'm talking about voice solutions for LTE, and voice over LTE is one of those solutions, but by all means not the only one, as you'll see. All right, there we go. And this is just a little bit of a high-level overview of LTE voice solutions. As many of you will know, the default with LTE was to launch LTE without supporting voice natively over LTE. LTE was accelerated and sort of came to market in record time to a large degree by leaving voice out. It was engineered and developed as a data-only network, and the industry came up with technologies to rely on existing 2G, 3G voice systems to deliver voice alongside and in sort of conjunction with LTE. And circuit switch fallback is the way that's done for wideband CDMA deployments. That the LTE devices support it and simply use the 3G and 2G networks for voice. In the CDMA world, it's more of a simultaneous voice and LTE, which is a CDMA radio and an LTE radio and handset operating simultaneously, LTE for data and CDMA for voice, and also EVO for data where LTE is not available. And of course, in the 2010 timeframe I've got there, you also have OTT VoIP, which is using the faster LTE networks to start to eat into carrier revenues for voice in particular, but also messaging. From 2012, we had the early launches of voice VoLTE devices and services, and I guess that's when we really are starting to see voice starting to go over LTE rather than just voice being delivered over the existing 2G, 3G networks. Those deployments were in Korea and also Metro PCS in the U.S. You had the deployment of a new technology called SRVCC to fall back from VoLTE to 2G, 3G voice where LTE coverage is not available. And as I mentioned earlier, you also had and have the launch of RCS and join on top of the VoLTE services to try and expand and differentiate the services. And next year onwards is really when we see the ramp for VoLTE devices and services. We also see the extension of voice over LTE into voice over Wi-Fi. Maybe not an extension, but almost kind of a parallel track. Some people will launch those together, some one after another, some separately. And also, of course, RCS will be evolving next year onwards as well. So I'll go through some of these bullets a little quickly. Why are carriers moving to VoLTE? Spectral efficiency is a big reason. VoLTE can deliver, and these numbers aren't hard and fast. As always, it depends on the details of the network, but as a kind of a broad brush overview, VoLTE can deliver twice the number of calls in a given amount of spectrum as 3G, and up to 6 times the number of calls as 2G in the same amount of spectrum. And clearly, that's quite compelling for carriers that are spectrum constrained, which a lot of them are. That allows you to reuse your 2G, 3G spectrum for LTE, and you can get a sort of a better balance between how much is being used for voice and data. VoLTE also will deliver VoIP with quality of service, which the OTT applications can't do, and IMS-based VoLTE can deliver end-to-end quality of service, which is a real compelling, unique selling point of VoLTE. This really is a key strategic weapon for carriers to fight back against OTT players because the OTT players cannot, obviously, they're over the top, they don't own the network and infrastructure and can't deliver that end-to-end, handset to radio network through the core, to the other subscriber quality of service, which a carrier is in a position to do with a well-implemented VoLTE service. Carriers, of course, can also, as I mentioned with the partnering strategy, offer quality of service to OTTs. They can, offer the APIs to their network to deliver that quality of service and charge a fee for it, to open up a new revenue stream. Of course, another motivation is simply improving voice, improving mobile voice, which some would argue hasn't seen a lot of innovation in recent years, and what's more, expanding the number of communication services on offer by RCS. So, for example, VoLTE can enable HD voice. I think, as you'll know, it's not the only platform that can enable that. It's available today in a number of markets over 3G and HSPA, HSPA Plus, but VoLTE can bring more to that equation. It also provides faster call setup times, which may seem a little bit technical, but when you're dialing that number and it goes through and the other person picks up a lot quicker, that actually can be a compelling experience, with the whole setup of the call that can be a little bit invisible to users, but once you experience significantly faster call setup times, it's quite compelling. And VoLTE plus RCS goes beyond voice, well beyond today's current mobile voice services, and basically lets carriers launch Skype-like services, but with quality of service, a real value add, and of course no need to download and install a particular app and make sure that your contacts and friends have that application to communicate with them. The theory is, and what will happen over time, is that VoLTE will work for anyone with a mobile phone. And the sort of services we'll see are presence, IM, messaging, video chat, content sharing, sharing pictures and files and videos during calls. A real expansion of the mobile voice service to more like the OTT type of services we're all used to with the addition of quality of service. But all that, all those advantages do come at a cost and aren't easy. You know, LTE has been so successful in large part because it excluded voice. And the solutions to take advantage of existing voice services, circuit switch fallback, works very well. You know, some operators think if it's not broke, don't fix it. Simultaneous voice and LTE works, maybe not, probably not quite as well as circuit switch fallback, but still, you know, pretty well. Meaningful VoLTE services require IMS, but a lot of carriers have deployed LTE without IMS. So one of the key ingredients for VoLTE is not always there. Another thing carriers need is a certain level of LTE coverage and subscriber penetration before VoLTE really makes sense. There is a technology, as I mentioned, to fall back from voice over LTE to 2G, 3G voice in areas where there's not LTE coverage. That's SRVCC. The only problem is if you're a subscriber and you know you're always bouncing back from this cool new advanced service to your traditional service, you're not going to be very happy, and a carrier would realize there's not much point in deploying a service like that. You need new devices. You need to re-optimize your LTE network, which was originally optimized for data. You need to redo that for voice plus data. Interoperability is a huge challenge in any new technology launch, particularly in VoLTE, whether that's at the supplier and equipment level within a carrier network or between carriers in a country. And you can also expand that to, you know, between carriers across countries, and you're facing another, you know, yet another level of complexity and challenge with VoLTE roaming. I mentioned devices. They have arrived. They're, you know, in market, particularly in Korea, where we've seen the large-scale launches. Many more coming to market next year. A lot of work being done. You know, a lot of devices have hardware support. A lot of the really high-tier devices and the software and testing and validation is really being being done at some pace. Just a couple quick slides on some of the early deployments we've seen in Korea, which is really driving the early learnings we're seeing in VoLTE. SK Telecom launched in August 2012. It branded it as HD Voice. You know, that's how it decided to go to market. That won't always be the case, but that was what they saw as the main differentiator. They put up some of the, you know, this is from SK Telecom, and they put up some of the technical performance. You can see them there. I think, you know, obviously you're getting the high definition voice via higher bandwidth and a more advanced codec. Also more advanced video codec, and the call setup times, you know, half the call setup time is 3G or less, and you know that really can make a difference to the end user experience. All the Korean operators launched last year. They all have exceptional 3G coverage, relatively small country with high population density. You know, 99% population coverage for SK Telecom. I mentioned how coverage is a requirement, and Korea is kind of unique in its ability to have such widespread coverage of an advanced technology. HD voice I mentioned, and very impressive technical performance you can see there. Of course, there are also challenges that we've seen in some of the Korean deployments. They're not charging for voice over LTE. They're not charging for HD voice. I think we've seen with HD voice over 3G, carriers couldn't really successfully charge for it. VoLTE brings a lot more than just HD voice to the party, but we're still not seeing carriers feel confident enough or feel like they have a new and differentiated enough service to charge for it. Of course, a lot of what they're doing is basically getting to the point where they can launch an OTT-like service, and end users get that for free, which makes it difficult to charge. Although the point I mentioned about quality of service will come into play over time and will be the carrier's friend in trying to monetize VoLTE. Carriers have launched the RCS service I mentioned to bring you know, rich communications on top of VoLTE, but there's not a lot of evidence that you know, this is taking share away from entrenched OTT services, although you know that could change over time. The deployments have been harder than the carriers expected from our conversations with them, and the summary there is that voice is tremendously complex, particularly compared to the initial deployments of LTE, which focused on data. SK Telecom has almost half of its subscriber base with VoLTE capable devices in their hands. More than half of its subscriber base, 5.6 million. The only challenge is subscribers aren't using it to a great degree. VoLTE usage is still optional and relatively low. They're still working on interoperability, as in if you're a SK Telecom subscriber, you can only call another SK Telecom subscriber with VoLTE, assuming that they have a VoLTE-enabled handset. So they need the handset. It also has to be someone on the same carrier, so they aren't quite there yet with interoperability. Moving on to the summary. Clearly, voice is not always focused on to a great degree in the mobile industry because all the growth is in data. But when you think about north of 60% of total mobile industry revenues, 630 billion in revenues this year, that's a reasonable number. It's still the vast majority of mobile revenues and well worth defending. I think we would all agree. LTE data services have been a huge success. I think we can sometimes forget with all the hubbub about LTE, and obviously a lot of smartphones have LTE, that it is a data service and that voice is delivered today via 2G, 3G, but LTE is a data service, tremendously successful. I would argue that VoLTE and not OTT is in the best position to be the future of mobile voice, and that's largely because people today have a phone and they rely on their mobile phone and they want to have that because they know that it works. They're quite happy to use OTT services a lot because of the richness and the price. But when it comes down to it, they want to be able to communicate and want to know they can communicate, and so they'll still have the mobile phone for that. And by sort of supercharging existing mobile services with the quality of service people expect with that, I think mobile voice and VoLTE can retain pole position in the mobile voice market. And VoLTE faces significant challenges that have to be solved. The business case, the maturity, coverage of the LTE networks, and penetration, as I mentioned earlier, the availability and I guess the quality of VoLTE devices. Some of the early stage devices were didn't work as well as planned, as we often see with technology launches, and all that has to be sorted out. And the interoperability, whether at the supplier or carrier levels, is still very much a challenge that needs to be solved. But I think that the summary that we've had from our work in the area is that the industry really does have this very high up the priority list. We have, as some of you will know, some very major large-scale deployments underway that haven't turned into launches yet, but really are driving the global VoLTE ecosystem forward to many of these challenges. And we see next year, 2014, as the real breakthrough year for voice over LTE globally. So that's it for me. We'll be taking questions at the end. So I'd like to go on to hand over to Pierre Lynch at Ixia for his presentation on essential steps for successful VoLTE deployments. Pierre, over to you.
Thanks a lot, Mike. I appreciate it. That was super, by the way. That was a great overview of what's going on. My name is Pierre Lynch. Hi, everybody. I'm from Ixia. I'm a senior product manager. And I'm going to take a look at a little bit more of the technical challenges of what's going on with VoLTE and what we see from our point of view with the deployments. So next slide, please. My agenda is pretty simple. I'll list the top 5 concerns based on what we're asked to do for VoLTE deployments, and then suggest a couple of techniques to prepare for it and monitor for that success. Next, please. So when I was thinking about what are the top 5 concerns, what are the big deals about this that we hear from our customers, one of the biggest ones is the fact that it's just the system itself used to deliver voice over LTE is just big. There's a lot of components that get involved. One customer told me that at least 60 different devices within the network, so 60 different network elements are active when placing and receiving a VoLTE call. So there's just a lot of moving parts. There's a lot of pieces into the puzzle that fit and have to work well and interoperate well in order to make the call. So as successful as it has been, they've had to take a look at this, and they were pretty worried at the beginning. The slide here shows a very, very simplified network diagram where I basically boiled all the subsystems down to little clouds. But you can see that, you know, there's many, even just on the cloud level, there's a lot of parts, starting at the UE, the handset itself, to the radio access network, the EPC itself, the core network for LTE, and then the addition of IMS in order to deliver this, and then the interaction with 3G, UMTS GSM, or of course CDMA 1XRTT for the handovers or the fallback, and then talking to the PSTN as well, so making outbound, out-of-network calls. What we found as well is a lot of people concentrate on other pieces and parts of the network that aren't always very obvious. What I call the non-3GPP parts, such as DNS and firewalls. DNS is actually now, even more than ever, an integral part of each and every action taken in EPC, in LTE itself, and in VoLTE as well. Firewalls for security as well. And on the right side, all the application servers that are necessary to deliver these services, from the telephony application server, voice call continuity, all the way down to legacy systems such as SMS. So there's just, and this is a simplified network diagram, of course. I'm not showing all the parts. But the point being that all of these subsystems have the potential of, they're all separate systems, and they also have the potential of being from different vendors for the network, and typically they would be. From the radio access network to the core to IMS, they all have the potential of being just different providers, which brings in interoperability concerns. So next slide, please. I just wanted to summarize this point a little bit because I do find it important, and we're being told that it is important by our customers. So just summarizing, a lot of moving parts, and then many interoperability interfaces between either different vendors, different subsystems, and some of the interfaces, not the interfaces themselves, but the interoperability is untested and unknown as soon as you have a roaming handset into your network. And then what we've seen, and particularly particular concerns with, is that some of the interfaces are really prone to customizations, namely, specifically the diameter interfaces, which tend to be customized quite a bit by all vendors. We've had one example of a PCRF vendor telling us that they've had 10 interoperability tests with different vendors, and each one of them ran into issues because everybody customizes their own diameter implementation. And the other one that people seem to be afraid of a little bit is the UE to, excuse me, IMS interface, which is SIP-based, which is prone to customizations as well. And then lastly is that some of the subsystems can become the unexpected bottlenecks, and specifically there I'm talking about firewalls and DNS, where everything else was well engineered to support the capacity required, but a lot of DNS failures came up, and DNS again is used at least 3 or 4 times for each and every call and each and every attach into the EPC. So it was particularly surprising in these cases. So next, please. My second in the top 5 is QoS. So this is a little bit of a repeat of what Mike went through very well a while ago. is QoS will be the big weapon in VoLTE deployment, and it's mainly because it's being marketed as HD voice. So you got to come through with that superior quality in order to be able to back up the claim type of thing. So because one thing to keep in mind is LTE provides a very good best effort service. So OTT will be pretty good. I've done video calls on LTE myself, and they were okay. So the point being, and the motivation being, you got to make that line bigger. You got to make it the QoS, the quality, and the experience of the voice call and the video call just better than any of the competition. And the competition is OTT, of course, and mainly for price, because like Mike said, it's going to be mainly free OTT. But we also, 3G, the deployment of UNTS reminds me anyways that the competition is always the previous generation. What you have in your hand now, it has to match and be better than that, because I remember the early UNTS deployments for voice specifically were a little bit rocky, because the voice, everybody was excited about the new data capabilities, but the voice fell behind GSM a little bit at the beginning, and people were scrambling to fix that, obviously, because you are competing against existing service. The differentiation, like Mike said, high definition voice, so better codec rates, and also the addition and packaging of other services around it. And as I was reminded today, actually, that SMS, MMS interoperability is one very important thing about RCS that people forget, is that WhatsApp can talk to WhatsApp only. RCS will be able to talk to legacy systems, and that's a pretty big deal. Content sharing and video calls, obviously, everything integrated into a package that's well known, the phone works, is a pretty big differentiator. You don't have to install apps, etc. And then, of course, last but certainly not least, is the ability to offer better quality of the voice and of the whole experience, because the operator controls all the 3GPP QoS mechanisms. And what that means technically is, for a VoLTE call, there will be dedicated bearers, dedicated resources allocated to the voice such that it should be better. Okay, the LTE, just like 3G as well, was built from the ground up with quality in mind and quality differentiation. This will give the operator the ability to differentiate by using these mechanisms that no OTT has access to unless a partnership is enabled. So these are the major motivations. Next slide, please. So what are these metrics? So what are people focused on to make sure that this proves to be a good experience? The first two are obvious: the quality of the voice and the video. How well is it performing? Everybody wants to know about that, and everybody's very concerned about that, because LTE is the first. It's the first. One of the major changes of LTE is the elimination of the dedicated circuit switch network for voice calls. So this is the first truly packetized voice over IP system, all through end-to-end through the air interface. So it's a big deal, and so people are concerned, and they want to make sure that it is going to work and the differentiation will be there. But other things that we were asked a lot about are the latency. Like Mike said, they are proving to be faster than traditional voice services, but everybody has been extremely skeptical about that. So the first thing people would ask us is, we want to be able to measure this time, these times, to establish the service request. Because LTE, as much as it is an always on and always connected system, the mobiles, the handsets, do go to idle state. So there's a step there. You got to reestablish the air interface connection and reestablish service. Then time to connect the call, meaning once I dialed and press send, how long does it take for the alert to the B party to sound? And then thirdly, once the B party has answered, how quickly will the voice start? So that's called the media cut through. And these three are the top three metrics that people were asking us to be able to help them with. These were the major concerns because of the added moving parts, etc. The others were obviously handovers. Voice brings handovers into a new light, puts much more pressure on them because a slight interruption while you're downloading a web page you can't perceive it, but in a voice call you can. So even intra-LTE, LTE to LTE base station handovers can be a concern for voice service. And then, of course, the SRVCT that Mike explained, the single radio voice call continuity. That's a handover from packetized LTE to circuit switch UNTS or 1XRTT or GSM. In my mind, is the most complicated handover that's been designed so far. And it includes extra signaling to the core network, to the IMS, to the voice call continuity server, to handle all of this, to the point where they've even revised how they perform the SRVCT handover to anchor it closer to the air interface instead of deep into the application server. Just points out the fact that it was a little slow at first, now they've sped it up. Again, a concern. And then the other stuff, surprisingly, that people were very worried about is existing services like the supplementary services, making sure the call waiting, diversion and forwarding worked, sending to voicemail, and also very importantly, the conferencing. So this was at the top of everybody's mind when we were talking to people. Next, please. So number 3, stress. How will it perform when the system is loaded in a busy hour in the morning, or rush hour 5 o'clock, 6 p.m. When the network and the cells become heavily loaded with traffic, how is this going to sound? How's the voice call going to perform? In the QoS mechanisms designed into LTE, the way it's supposed to work is when voice call capacity or the amount of voice calls goes up while having a constant data traffic, the voice call quality should remain the same. It should get prioritized over the best effort web browsing. And in fact, the graphs on the right show that simple test, just a very simple test of loading the network, increasing the voice traffic, the VoLTE traffic, and maintaining a constant data traffic active. Measure the latencies, measure the response times after that. And what should happen is that the VoLTE response time, meaning the voice, should remain the same, but the best effort data, meaning the web browsing or whatever, should actually start seeing a little bit slower response time. And if you see this, oddly, it's actually success. It means the QoS mechanisms in the network are working just fine because the QoS for the voice has precedence over the best effort. So just a simple test, and we can do the exact reverse test as well. So these are things that only can be seen when the network is under a severe load. And even things like service availability and retainability become factors there. And these are basic QoS metrics. Can I make the phone call? Is the service available when the network is loaded? And once I've made it, can I keep it? Can I keep that voice call active, which is the retainability part? Stressing the system also brings out the ugly congestion point. This brings out the surprises and basically highlights the unknown congestion points within the network. Again, there's many, many moving parts, all of them engineered to be able to support certain capacity levels in the network. But when you put it all together and put it under stress, sometimes things pop up that were not accounted for. We've seen a whole lot of overload requests as well. People want to see what is the behavior when it goes over capacity. What happens? Does everything still stand up and maintain current load and then refuse calls, or does everything behave well? So this is, as much as this refers back to the QoS, but QoS on one call over an empty network is one thing. It's an entirely different thing to maintain that while the network is really busy doing other things simultaneously. Next, please. The fourth one that I've stuck in there is the most complex part of the LTE system is the air interface itself, the LTE-UU. It is the most complex interface done in all wireless systems, and definitely the most complex in LTE. And we've run tests to show that the graph on the top left, that as you see voice quality when you're close to the base station, voice quality is very high, and these 4 lines with different colors show different codec rates. So they start out with, the expected better quality versus the lower quality for the lower rate. But as you go to the right and you move away from the base station, you get closer to cell edge, then the voice quality starts going down markedly. And this is an important thing to realize, because it may force an adjustment in handover thresholds, meaning if I was on just a data session, I could afford to be towards cell edge and just slow down my download or slow down the web browsing, but and that's not going to be very perceptible. But a voice call, it will be. You'll be able to notice that. We expect to hear things in a certain way. And so you may want to adjust the handover mechanisms and the algorithms to maybe hand over just a little bit quicker if it's a voice call or just all over. But it does reorganize your thinking because of the fact that you can just perceive the difference a lot quicker. The other thing is the node B, the E node B has this thing called the scheduler, which is probably one of the most important elements in the entire network, where the scheduler allocates time blocks and data blocks for this handset to communicate in the uplink. It does all that scheduling based on many, many, many different inputs. A little bit of a diagram to show it there, where QoS attributes come in from the left as an input to the packet scheduling for the uplink. So it will consider the fact that, hey, this is a voice call. This bearer, this resource just gets higher priority than anything else that's going on for myself and for other UEs that happen to be sharing the same cell. So that is an integral part of the packet scheduling, and then becomes a part of the link adaptation as well, which affects coding rates and things like that, based on the quality, the quality indicator coming up from in the uplink. So all of these things are done on the E node B. Really, this can mess up things from the very beginning. You can have the best network on earth, but if this is not working right for the dedicated bearers and for the dedicated resources for the voice call, there's going to be a problem from the beginning. There's also even specific features built in to, not specific to VoLTE, but features that will help VoLTE perform better over the air interface. And a good example is what's called TTI bundling, which is simplistically an algorithm that says for real-time data, conversational data, if a packet is dropped, there's no point in retransmitting that packet, because by the time you've figured out that you've dropped it, it's too late to do it. So TTI bundling is basically saying, okay, you're at cell edge right now. I think you're going to drop packets, so please send that packet 3 times instead of once, and I'll probably get one right. So all of these things do help and are meant to help for services like VoLTE, but are a concern. It's something that people told us specifically, right, we want to make sure this works well. Next, please. And lastly, what I listed as the 5th concern is maybe surprising, but we found a lot of attention being put on this part of the network. Now, this isn't even a 3GPP element. The diameter routing agent, or DRA, has become and is becoming, and I don't think I've seen one operator not deploy these things. And it's basically an intelligent diameter routing switch, which goes beyond IT level routing, but switches based on subscribers and locations and things like that. Its benefits are incredible. This is just such a logical thing to do, because it can handle mediation between all types of different devices and different networks and roaming partners. It can do load balancing, where the EPC, instead of worrying about 5 HSSs, which are probably required, just communicates to the DRA, and the DRA handles, okay, where is the subscriber located, and he'll query the appropriate HSS. And also, of course, scalability, link scalability is one thing that the DRA isolates all the other units from. So the benefits are just huge. The DRA is becoming a huge, big deal in all of LTE networks that we've seen. But at the same time, people are putting a ton of attention on it, because it does put one single point, and it may always get deployed in redundant pairs, of course. But because of the fact that, the knowledge that if you can't do the HSS query for the call, and especially the PCRF, the policy server query for a VoLTE call, well, it stops the call dead in its tracks. It just doesn't exist. You cannot even place the call. So it just becomes this really critical piece of infrastructure that must perform to a certain degree to the expected levels of capacity. And these DRA units are pretty intelligent. They are stateful. They remember what's going on. And that's why even deploying them in pairs puts a lot of pressure on both of them, knowing exactly what the other one's doing in case of a failover. So we've just seen so much attention placed on this for interoperability reasons, scalability. They want to stress this. They want to make sure it's going to perform up to speed and for what they're planning for as far as capacity in the network. And they also want to make sure that the failovers will work. Will just perform as expected, so that no surprises. Now we've actually seen entire, LTE networks just stop operating because of diameter issues. So diameter is just one of the most important signaling building blocks of the network, and the DRA does magnificent things to help the network designers in there, but it also comes with its share of headaches, and people want to make sure things are cool. Next. Now I move on to, okay, what can we do about it? Well, the first thing is, I was just thinking of this just before this webinar. Before you people joined, we all joined half an hour before the webinar started. We wanted to make sure that the voice quality, all our phones were working, all the slides were sliding, everything is just working. It's just a natural thing we just didn't want to have any unexpected things happen while we were doing this webinar. Of course not. So we just got on before, make sure everything was right. Kyle had to adjust my voice because I was reverberating. Perfect. And now things work well. So that philosophy must extend to important things, much more important things like delivering mobile services. So
yeah, it looks like he had some connection issues, ironically, about what he was talking about. So I guess with that being said, Mike, is it okay if we have just a couple minutes to launch into some questions that you may or may not be able to answer? Most of them were directed towards Pierre, but we do have a couple questions, towards you, Mike. So the first one, if you don't mind answering, is why couldn't an operator embrace OTT instead of viewing it as a threat?
So the answer is they can. Some operators have viewed it as a threat, and it has been a threat to some carriers because it's hit their voice and messaging revenues. But they can very much also take the view that they should partner with OTTs, to take advantage of some of the features that we all know and love, and to bring the best of both worlds, this rich feature set, plus the reliability of the mobile network to their subscribers. So you can very much partner with OTTs, and we've seen many carriers pursuing that strategy with varying degrees of success.
Okay. Another one in slide 17 of your presentation, you have VoLTE and Wi-Fi, but not VoHSPA. Why not VoHSPA?
That's a fair point. I mean, that is being standardized and is on the roadmap. And certainly at some point in the future, that could be part of the the VoIP deployment. So you're maintaining the packet-based session onto HSPA. What we've heard from the carriers we've been talking to during our research is that is not a high priority at the moment, and partly or largely for the reason Pierre referred to, that really delivering that can be a challenge at the same level of quality of the existing 3G circuit switched voice, and that there's a number of basically challenges associated with voice over HSPA that has slowed it down a bit. I think those will be addressed, and it will be deployed, but it's not at the top of the priority list.
Okay, and then one other question we have is, how do you think operators can differentiate VoLTE service to continue securing voice revenue over OTT's free services?
Yeah, that's a good question, and it comes back to what I was mentioning about quality of service. A lot of OTT applications work great on the mobile network, but I've certainly noticed as an end user based in the U.S. that as the U.S. LTE networks have loaded, there's been more subscribers, more congestion potential when I've been in major urban areas. The OTT applications can simply fall over because they don't have guaranteed quality of service, and they have to the packets for them have to wait to go through the network along with all the other packets, whether those be email or video or anything else. And I think when carriers can get the end-to-end quality of service in VoLTE working, and they're operating in congested networks, which LTE in leading markets is becoming, we really will start to see the differentiation emerge of the carrier VoLTE-based RCS services compared to the OTT services. As I also mentioned, carriers, of course, could decide to open up that quality of service feature to OTTs so that they could also provide that, and carriers would, of course, charge for that service.
Okay, thanks, Mike. It looks like Pierre's back on, so Pierre, if you wouldn't mind jumping back in here and finishing your thought.
Yeah, I am back. Sorry about that, everybody. My call dropped, and isn't that the most ironic thing on earth? Just when I was talking about testing the webinar and voice before. Very quickly, lab testing. Pre-test before you use the service, like we did, but we didn't do it enough on my end. In fact, what we advocate, obviously, is being able to test these features, anything in a lab, with a smaller scale hardware, software as replica as the operational network, and then having the exact same hardware and software versions as in the operational network. And then it becomes a cycle where you implement and test new features and hardware changes in the lab, you validate them, they become existing features, but each existing feature then gets regression tested. So you make sure that the new features work, and secondly, that the existing features are not broken. Those are the two main things that you do in that lab, and that's what we are always asked to do. Thirdly, and very importantly, is the replication of field issues. So solving issues is always easier if you can reproduce the issue in a lab. It's just that simple. So next, please. Just a look back and just to show an example of how we would do this. This is just to refresh your memory of my little simplified network diagram. Then we move on to the next slide. I'm a big proponent of having as many things under test, as much as the real network under test as possible. So this is one architecture of many that we're asked to do. But this one here is very much an end-to-end test where we reproduce things at the very, very edge, simulate inputs and outputs there, and place the entire system, including error interface, under test, all at the same time. And this provides the ultimate system test and make sure that all those moving parts that I was talking about earlier are moving together, orchestrated correctly. Interop is okay, dimensions are okay, capacity is proven. You just put as much as real. We're also asked to do, like, there's a lot of different types of test architectures, and we are asked sometimes to isolate certain elements, and the most popular ones for that are the DRA, isolating that and placing it under serious stress, the MME as well. But at the end of the day, you want to be able to verify that QoS end-to-end, all the service availability, the connection times, et cetera, et cetera. You really need a full system. So we come in and we're able to replace the edge elements and then place that system under test. Next. Continuing on with another important philosophy of trust but verify. Once it is deployed, once the service is deployed, it's a great idea to have monitoring services to make sure that everything is going smoothly. So this, in an operational network, having all types of monitoring gear, so analytics, this will be a typical architecture where you place a monitoring switch or a packet broker into the network, or something even more specialized like a GTT session controller, which is highly specialized for mobility environments, that will filter out the packets and send them up to the higher layer data analytics and the reporting systems. This provides full visibility into the operational network. If issues arise or if they don't, this just provides peace of mind and just the ability to check everything out while it's in the field. And that finally concludes my part. Thank you very much.
All right, thank you, Pierre. Looks like we were running short on time. I will ask one question that we got, Pierre. It's kind of overarching. What do you feel is the #1 challenge in deploying VoLTE?
Of the top 5 that I've just mentioned, I think QoS is the biggie. You know, making sure that all the piece parts work together end to end because of the sheer size of the system, the complexity, 60 network elements getting involved in one call. It is #1. Reaching QoS and the experience, making sure the experience is a good one as expected, is the main one that I see.
Okay, thanks. All right, that's about all the time we have. I want to thank everyone for attending VoLTE Up Close, 5 essential steps for successful deployments, presented by Ixia and Informa. I want to thank Mike and Pierre for taking the time to participate today, and just a reminder that everyone will receive a copy of the on-demand of this webinar within 24 hours.